Hello, today we're going to start the Home Economics course with the chapter 1.2.1. Now, as explained in the introduction, the Food Studies course makes up 45% of the overall Home Economics grade. Now, this is a significant amount, so needless to say, we're going to spend a lot of time talking about food. I also explained to you that we're going to start with the basics. So regardless of the level that you're at, we're going to begin with what exactly is food. So what is food? Now, as we are not having an interactive class just now, I'm going to give you some ideas that students will have given me in the past. It's not something that people will actually think about, but we do want to know from the beginning what exactly we're dealing with. So what is food? First and foremost, people describe it as any solid or liquid substance. So think of things like solid fish, solid cheese, meat, and take, for example, then liquid. We have soups, we have smoothies, and of course we can't forget milk. This solid or liquid substance is then ingested into the body. So we consume it. But why? Now, here we have different terms. Some people would say we ingest this substance, solid or liquid, for a source of fuel for our body. But the most common is that it's a source of energy. So what exactly is energy? Energy allows our body to carry out work. In fact, we can define energy as the ability to do work. But the thing about the body is that it doesn't have just one specific type of work. We can categorize it into two. So for example, we have what we call external work. So the solid or liquid food is going to provide a source of energy to allow the body to carry out external work. So for example, you're walking, you're running, you go for a swim, you go to the gym. All of that energy will be described as energy for external work. Then, of course, the body also will carry out work internally, the work that we can't physically see, but is very much going on all day, every day. Things like energy required for new cells to be built, hormones, enzymes, antibodies, our breathing mechanism, the beating of our heart, all requires a source of energy. Now, this energy comes from food, but the food is made up of, or we can say it is composed of, smaller parts. A term I hope you're familiar with, even if it is just from general knowledge, and that is food is composed of nutrients, and there are 6 of them. Now, what is unusual is the fact that there is no one food on the planet that contains all 6 nutrients. The nearest we have to, shall we call it, the perfect food happens to be milk. Think of the young of animals, the young of humans. They can live on milk alone for a period of time. However, milk is low in iron content and devoid of vitamin C due to pasteurization and other heat treatments. So as we go through this course, we'll be learning not just all about each of these individual components or parts that food is made up of, but then we're going to progress onto the various different food groups, learning about the composition of meat and eggs and fish and cheese and fruit and vegetables, fats and oils. And then the progression after that, we'll be looking at what's referred to as applied nutrition, all the various diets that we have and the different foods that we should have included. So just in summary there before we move on, food happens to be a solid or liquid substance. We ingest it into our body so that our body can carry out its work. The body is therefore being provided with the source of fuel or energy from this food that we have consumed. This food is then made up of 6 components or parts, which happen to be called nutrients. So food is defined, we can say any solid or any liquid, which happens to be made up of these nutrients. There are 6 nutrients. Now, there's a word that we're going to come across quite a lot during our course, and this is the word classify. Now, classify can be applied to classify bacteria, classify mold, classify yeast, classify fruit, classify vegetables, classify cheese, classify fish. I could go on and on. But for today, we're going to be classifying nutrients. Now, what exactly does the word classify mean? It means to divide into groups. And when it comes to the classification of nutrients, we're looking at classifying or dividing nutrients into two groups, namely the macronutrients and the micronutrients. Now, I suppose the answer is in the name. Macro would suggest a large amount and micro would suggest a small amount. So macro, we require these nutrients, these components of food. The requirements are in large amounts. Now, when we say large amounts, we're not talking about kilograms. When we refer to the macronutrients, we always refer to them in grams. The micronutrients, we're looking at required or needed by the body in very small or sometimes even, I suppose you could say, minute amounts. And when I say minute, you'll be surprised at how small we're looking at. So firstly, some micronutrients are measured in what we call milligrams. Now, milligram is 1,000th of a gram. That is difficult enough to envisage, but there's a second one, and it's called a microgram. And a microgram is 1,000,000th of a gram, just extremely difficult to try and comprehend an amount so small. Now, there's a measurement for micrograms. Some of you may be familiar with it. It's a straight line, as you can see here, with the U. But sometimes, you know, the writing might not be the best. So I would suggest to students to make sure that there's no ambiguity and the examiner knows exactly what measurement you're speaking about. Write your microgram as an mcg. So mcg would be quite small. Right, we'll just get rid of that there. And that's our mcg. So 1,000,000th of a gram. Right. Now, moving on. Which nutrients belong to which class? Well, first off, the macronutrients, we're looking at protein, lipids, and carbohydrate. Now, that term lipid is very important. I regularly have students and they will say, oh, what are the three macronutrients? Protein, fats, and carbohydrates. Absolutely not. The term lipid is a collective term and it covers fats that are solid at room temperature, like fats. So lipids, for example, would be fats that are, or they could be oils. So fats would be butter content, fat we talk about, lard, and now of course we have the oil content of walnuts, of sesame seeds, and so on, sunflower seeds, etc. So please use the term lipids, and they are our macronutrients, and anytime we see reference to them, they're referred to in grams. Where will you see reference to them? Pre-packaged foodstuffs, whether it's your box of breakfast cereal in the morning, whether it's a bag of popcorn, you will always see the measurement gram beside the protein, lipid and carbohydrate content. Now, since December 2016, according to EU legislation, all food manufacturers are legally obliged to give nutritional information on pre-packaged foodstuffs. So protein, lipid content, which is usually referred to in the fat content, in saturates, carbohydrate content, they will refer to sugar content, and the measurement will always be in grams. Now you might say, December 2016, we surely had nutritional information on pre-packaged foodstuffs before that. Yes, we did, but it was voluntary. Just to mention briefly, when they do give this information on pre-packaged foodstuffs, the nutritional information legally must be provided per 100 grams if it's a solid food and per 100 mils if it's a liquid. Moving on then, we have the other nutrients, which happen to be the micronutrients. Now, the micronutrients would include minerals like calcium, iron, iodine, sodium, potassium, and then of course we have our vitamins. Now, part of our course is to go through each of these 6 nutrients in intense detail, because question 1 on section B, worth 80 marks, a compulsory question, 20% of your Leaving Cert grade, is going to definitely have a nutrient question. Therefore, we need to do it well. Now, when we talk about minerals and vitamins, we said small or minute amounts for the micronutrients. So we're looking at milligrams. Now, milligrams are 1/1000th of a gram, an amount that is extremely small. However, there is a smaller measurement again, and this is called a microgram, a straight line with the U at the side. Now, sometimes, depending on how neat you are, that might not be very clear. So I do say to my students, you know, MCG is the way to go for this particular measurement rather than this one. But either or, once you make sure that this measurement is quite clear. Now, what is an MCG or a microgram? 1/1,000,000th of a gram. Very, very difficult indeed to try and imagine that we would need that amount of a nutrient. However, there is language that we will come across on our exam, and it's referred to as the RDA. And the RDA, many of you probably know, stands for recommended daily allowance or daily amount. Now, can I just say to you that this is very outdated due to the fact that when we talk about the recommended amount of calcium for an adult, say for an adult female, we're looking at 800 milligrams. What we're not taking into consideration the age of the woman. Are they, you know, in their 20s or 30s? Are they in their 50s where they're postmenopausal? What's their body size? And so on. So we're not taking that into consideration. So on the home economics course, RDAs are very limited. They are quite restrictive. However, you know, you'd not expect to be a walking encyclopedia. If you were a dietitian, you'd be talking about what are called DRVs, dietary reference values, where all of the factors I've just mentioned beforehand would be considered. So we're just looking at a general amount of each particular nutrient. So if we take one of our nutrients, and that is the micronutrient, which happens to be vitamin B12. Unbelievably, we're required 1.6 micrograms is what is required for an adult. Now, this is where the confusion arises. You've explained to students we have food made up of 6 components or parts called nutrients. We have macro, we have micro. So I would need, for example, 75 grams of protein to 80 grams of protein, depending on who I am. And I might only need 1.6 micrograms of B12. So there is this, I suppose, confusion that 1.6 millionth of B12 is less important than the 75 grams of protein or than the 800 milligrams of calcium. Not the case. When we talk about the classification of nutrients, we are literally just doing that. We are dividing them into 2 categories where we're looking at the quantity required by the body. We are by no means suggesting or inferring that the micronutrients are less important or the macro more important. And that is important to be clear on that. Now, so we have our 6 nutrients. So we're going to show here how our protein, our lipids and our carbohydrates are the macro nutrients. Our minerals and our vitamins are going to be our micronutrients. And go back to our measurement. We have grams, we can have either milligrams, or we can have these very, very minute quantities, which happen to be micrograms. So we have our classification here. Now, this is extremely important, and that is that the classification only refers to the quantity of the nutrient. It is not referring to the importance. So make sure that we know this. 60 grams of protein, 800 milligrams of calcium, equally important as the 1.6 micrograms of vitamin B12. We said food provides the body with a source of energy, which happens to be the ability to do work. Now, if we just look here, the first of my many doodles, and we'll call them doodles, I won't insult anyone by saying that they're diagrams. Here we go. So we ingest food, and that food is going to provide the body with the source of energy in order for the body to carry out its work. We stated earlier this work can be external and it can be internal. However, food, we said, is made up of components or parts. Now, ideally, I should have 6 components because that is what we said food is made up of. However, we need to be clear here. I'm going to remove 3 of these nutrients. And you might say, why are we doing that? Because of the 6 nutrients, only 3 of them will actually provide the body with the source of energy. And they are the macronutrients: protein, lipids, and carbohydrates. So they provide our body with this source of energy. So it's really important that we know that it's the macronutrients that would provide the energy for the body to carry out work. The majority of energy comes from lipids and carbohydrates. The energy released from protein is for internal work. Now, part of this course, of course, we have to learn the content. You know, we're sitting an exam next June, June 2025. But most important for me, I want you to be able to relate to what we're covering on the course. Home economics, after all, is a living subject. So, for example, between now and the next lesson, if you're sitting down for your breakfast tomorrow morning, just go and look at the side of your box of breakfast cereal. Maybe you'll have a bag of popcorn later in the day today. Have a look at the nutritional information. Look at your macronutrients and your micronutrient content. It should say per 100 grams. Sometimes the food manufacturer volunteers per portion, like per 30 gram serving. However, even though the 3 micronutrients, protein, lipids, and carbohydrates, provide the body with a source of energy, the energy from protein ideally should not be used for external work. In other words, I shouldn't be moving around here, walking, running, etc., and using the energy from protein. Ideally speaking, the energy from protein is described as a secondary source of energy. It is for the work that goes on inside the body. But as you are probably aware, there are many particular diets out there at the moment that are promoting high protein, low carbohydrate. And what has happened in that situation is that most of our energy for external work is coming from carbohydrate. But when you swap over, for example, people start to reduce their carbohydrate content, increase their protein intake, the body has to change over as well. So instead of getting their primary source of energy from carbohydrate, they're getting their primary source of energy from protein. In order for the body to do that swap over, it takes the body about 5 or 6 days. And when your body is using protein as a main source of energy, your body is meant to be in a state of ketosis, i.e. it's in starvation mode. Now, while that can keep body weight down, long term it can have a serious effect on our kidneys and our liver. But that is another day's work. We just want to summarise here today, and that is, of the 6 nutrients that food is made up of, 3 of the 6 will provide the body with the source of energy: protein, lipids, and carbohydrates. However, the energy from protein should be a secondary source of energy used for internal work only, and the energy from carbohydrate and lipid is for external work mainly. So If protein is used for external work, we said the body is in the state of ketosis or starvation mode. Now that we'll be looking at in the handout on protein, which will be our next handout after we've completed this. So food is broken down by the digestive system into a usable form of energy. Now, the functions of energy. Functions of energy we're going to note here happen to be 3. So we're just going to highlight those 3 functions here. Now, with regard to the functions of energy, I want you to write here that we're looking at short questions only. And I would learn 3. So we'll need to know 3 of these functions of energy. First of all, muscle movement. Secondly, needed for digestion. And thirdly, growth of cells. So energy is needed for muscle movement. We have voluntary and involuntary. So I choose to walk, I choose to run, I choose to swim. Involuntary, my eyes blinking, my heart, the muscle of my heart pumping, contracting, relaxing, the muscle of my diaphragm as I breathe. These are all involuntary actions, but they still require a source of energy. Then we have energy needed for digestion. As we go through the course, we'll be looking at how nutrients, particularly macronutrients, are very complex initially. For example, you've heard of words like starch, you've heard of polypeptides, of protein, and we need to break these down in order for them to become a usable form of energy. And that goes on during digestion, but this of course will require a source of energy. And then cell activity would be another one. The growth of cells, DNA, RNA synthesis, muscle contraction. So these are functions of energy. Now, we will be having a special class every week, and it will be a live class, and I'll be going through the questions associated with each of the different chapters. So our first live class on those particular questions, it's linked in with your workbook. We'll go through how we need to approach these short questions. But for now, to make sure we know the content. Now, just to finish for today, energy released from food is measured in kilocalories or kilojoules. So what are we talking about here? So if we go down a little bit further here and we take our food again, specifically our macronutrients, and just to note there, we need to write protein would be the one to go with. So we have our protein, we have our carbohydrates, and we have our lipids, providing the body with a source of energy. And what we're now saying is that that energy is measured in kilocalories, or what we call kilojoules. So if, for example, I were to measure the length of this room, I would use a metre rule, where we'd use centimetres and metres. If I was measuring liquid in a kitchen, millilitres and litres. There's a special apparatus which is called a calorimeter. And that calorimeter is used to determine how much energy is released from each of the 3 macronutrients, beginning with protein. Now remember, we said that protein is a macronutrient, it's measured in grams. So I ingest 1 gram of protein. It provides the body with the source of energy. But this energy is measured in what we call kilocalories or kilojoules. So we're looking at 4 kilocalories of energy for every gram of protein. But ideally that energy needs to be used for internal work. Then we have kilojoules. Now kilojoule is the smallest unit of energy that the energy released from food can be measured in. And we'll just make a note here at the top that we're looking at 1 kilocalorie equals 4.2 kilojoules. So you can do quick math there. 4 kilocalories, we're looking at 16.8 kilojoules. Now the next macronutrient will be carbohydrate. Again, because it's a macronutrient, it's 1 gram of carbohydrate. When ingested, provides a source of energy for the body and is measured in kilocalories or kilojoules. Now you and I will speak about kilocalories. And that's something I want to say to you as well. We often have abbreviated or slang words, I suppose, in general conversation. In an exam for home economics, do not use the word calorie, be more specific and use the term kilocalorie. So like protein, it provides 4 kilocalories of energy, which is 16.8 kilojoules. But there is a significant difference. The energy that is provided for the body from carbohydrate is purely for external movement. And finally then we have our third and final macronutrient, and that is lipid. So we're talking about either a gram of fat or a gram of oil will provide the body with the source of energy. Now, one of the reasons why we're told to, I suppose, limit our intake of lipid is the fact it's going to provide per gram over double the amount of energy that both protein and carbohydrate provide. Again, we're looking at kilocalorie and kilojoule. So we're looking at 9 kilocalories. Now, in terms of multiplying 4.2 multiplied by 9, so we have 37.8 kilojoules. So there are macronutrients and the amount of energy provided by each. Now, a kilocalorie is the amount of energy. So we're going to go with this here, we're going to highlight it. So the amount of energy used to raise 1 litre of water by 1 degrees centigrade. Now, this we're going to write here at the side happens to be a definition. And we have a general rule in home economics, and that is definitions are always broken down into 3 parts. So 1, the amount of heat required. Number 2, to raise 1 litre of water. Number 3, by 1 degree centigrade. And if you wanted to do a little bit of showing off, you could mention the word calorimeter, but most importantly, the amount of heat required to raise 1 litre of water by 1 degrees centigrade. Noting that 1 kilocalorie equals 4.2 kilojoules. A kilojoule, we said, being the smallest unit of energy released from food that it's measured in. To convert kilocalories to kilojoules, we note that we multiply by 4.2, and going back to the nutritional information labels that we see on prepackaged foodstuffs, you will note that they will have not just the macronutrient content per grams, per 100 grams, possibly per portion, but they will also, and they're legally obliged to give the kilocalorie content and the kilojoule content. Can I just reiterate, for this to, I suppose, log into your brain, it would be a really good idea to start becoming a more discerning consumer, looking at the labels and, I suppose, being confident in knowing a little bit more information than maybe you knew before we started. Right, that finishes today's lesson, and we'll continue the next day with the energy requirements and basal metabolic rate. Thank you.